had, I think, you already had 4 sessions regarding LLMs, right? So you already gotten an overview what is LLM or how LLM works. So let me talk about Indian languages and why it is challenging, or what do we have techniques working in English, why still it's a challenge to Indian language. So let's get an idea about the Indian language. So you can see here why Indian languages matter in AI. So you can see from the slide that we have 750 living languages in India. Means these are the languages which are spoken by different communities across India. And out of that, 1600 million users, Indian users, are there who are writing in their native languages in the various online sites. And as we know, we have 22 scheduled languages, out of which we can find that only 5.5% of the Indian in English. It means that still we have 94.5% of the Indian population who prefers for in their own native languages. And you can see in the last that 95% internet content not in Indian language. It means that only 3% of the Indian language, or you can say available in digital mode in the digital platform. So the main insight here is the India is the largest multilingual democracy. So we have multiple languages, multilingual democracy, where only 5% of its linguistic populations are comfortable in Indian language, in English languages. And this is a gap for a technical challenge as well as the social imperative. So you can see this graph here. You can see that the orange graph that India is targeting for projected market for Indic languages for the AI products by 2030. And you can also see in the blue graph that there's a surprise in the graph that 70% of the new internet users, it is that every time the internet users are increasing in India and they are preferring native languages content. So here you can see that the engagement is being rising into 3.2. It is the engagement is rising every time in terms of regional language content in comparison to English. So the language gap. So we can see, so here I'm just giving a overview of the English NLP and the Indian language NLP. So what is NLP? So I will be talking what NLP is. NLP is actually natural language processing. So natural language, we basically say that natural language are those languages which are spoken by people to communicate each other. So now I'm speaking in a natural language. So English is a natural language, or if I speak in Hindi, like यदि मैं अभी हिंदी में बात करती रहती हूँ तो like it is a natural language spoken by Hindi people, or if it is a national language of India. So here the natural language processing means that those languages which are spoken by people and are used by people to communicate with each other, with different human beings. And in the same way, they are making the system to communicate with the people or a different system in such a way how the uh, humans communicate. So those are called natural language processing. So what is AI when we talk about? So AI is basically the natural language processing. We're communicating different people in their regional languages, and it may be in text or it may be in speech. So either we can type those things and send in a message, and then the communication be done, or it may be in a speech. We can give voice messages. It may be interpreted. Sometimes it may be voice to text. It may be text to voice. It may be voice to voice, or it may be text to text. So you can see here that why there is a challenge, because in English, why we are getting the perfection, because in training data we have trillions of tokens in English. So tokens basically we means the words. Okay, in simple terminology, if we say tokens means words. So in English we have the data that are being trained in trillions, uh, which are being covering most of the vocabularies, whereas in Indian languages, this is, I'm just giving an overview of the overall Indian languages, so it's just in millions and billions. So we are not able to cover the entire vocabulary of a particular language also. So till date we have seen that there are so many models, so many pre-trained models which are being applied to various NLP platforms, you can say, like, but in English we have 100 plus mature models. It means that in English the vocabulary is captured in such a way that they are able to interpret the correct meaning. Whereas in case of Indian language, we have round about 15 specialized models, where also we don't get 100% accuracy. We lack somewhere. For example, I will give you one translation like in Assamese. Okay, in Assamese, in my language, in Google Translator, you can also type and see. So uh, uh, are you fine? Are you fine? Okay, so if I translate that sentence, are you fine? So what happens? This has been corrected recently, but when it was initially the Google Translator was done, so are you fine? So fine means find. So are you fine means in SMS, fine have two meanings. Fine have two meaning. One is the fine, okay, you are fine, you are okay. And another fine means you were fined. Fined means suppose you are charged of, suppose you had break the traffic rule and you are charged of some money. So that is another fine. So the translator does not capture the actual meaning. So this is a quite challenging thing, because in Indian languages, in each of the Indian languages, we have multiple meaning against the word. It means that ambiguity of words are so much. And also we'll be talking later on about the parts of speech, that each word may have different parts of speech. Maybe one word may be a noun, and another word may be a verb which is talking about some action. So in that case, the models don't catch the actual meaning. For example, suppose I catch a fly. So fly you means an insect. I catch a fly. So it's an insect. It's a noun. The pilot fly the aeroplane, so that is an action, and it means that it is the pilot is doing some action on the uh, action on the aeroplane. So that two meaning, that ambiguity in case of English word, those all the maturity in the models have been covered. Whereas in case of Indian languages, there is a long way we have to go, and we have to uh, you know uh, outcome the challenges. And then the benchmark data set. In case of benchmark data set, we have thousands of English data set, and in case of Indian language, we have hardly a dozen. But there is also though we have dozen, still it is challenging, because in case of English dataset, those are gold standard annotated dataset. So what is gold standard annotated dataset? So gold standard annotated dataset means those are being verified and done by many researchers independent of their geographical locations. Mean it is not biased. Sometimes what happens, we know it, so we just put it, okay, this will be this one, this will be this one. So that bias will be independent of anything. Different linguistic expert will provide the same information, and in that case it is a gold standard annotated data set. But in case of Indian languages, yes, still work is going on. We have ample amount of work also, but those data set, those results which we are getting, those are not up to the mark. We cannot say that those are benchmark results based on some benchmark data set. Then tokenization. The tokenization is highly optimized. We will be talking it later on. And in case of Indian language, quite challenging. We have various commercial tools in English, whereas we have a very few um, commercial tools in Indian languages, and we have hardly in Hindi, Bengali, but most of the Indian languages still we need to work on, and we have a great ample amount of scope is there to work on here. Then research papers in English language is 50,000 plus, whereas in case of Indian languages with some standardization, we have only hardly 20,000, 2,000, sorry. So this gap represents one of the most impactful open problems in AI research today. So coming to the next slide. So already I mentioned what is natural language processing. So this is the field of AI where the computer understands, read, understand, and derive meaning from human languages. Okay, so how it works from the right-hand side of the slide, you can see that whatever we give as input, it may be a sentence, it may be a document, or it may be a single sentence, it may be multiple sentence. Then they go through a pre-processing phase where the words are being prepared to be applied to the system, because though we the human brains understand all type of forms, but the computer, if it gets modified to some inflection, I mean, if the words get inflected in another way, the computer may not understand. So the cleaning and the normalization need to be done. So that is a part of pre-processing. Then the representations, how tokenizations, embeddings, model, and prediction. Prediction depending on the target of application we require, it is being done. So the entire topic of my presentation today will be talking on the tokenization, because if we are not able to predict the actual meaning of the word, the meaning may reflect in a different way, then the entire output in whichever application we do, it will result in some wrong output, which may result in everything, the wrong outcomings, and the requirement of that software tool may actually result in some negative way. So this is quite challenging, and the actual meaning is very important, and how actually this meaning of the words are being actually done. So we'll be talking that thing today. So you can see here, this is how we were talking, we are having this session or this workshop on LLM, right? So you can see that how it had actually evolved, how natural language processing had evolved from the 1950s till date. So you had seen, so just want to give a brief idea what actually is of these methods speak of. So starting in the 1950s, so when they were trying to make the system understand how the natural language, like means like just like humans, so rule based methods or rule based NLPs were done. So in that case, these are basically the deterministic system. So I think all of you know deterministic, non-deterministic, right? So these are basically the deterministic way of understanding the natural language by the system, and it tries to analyze, process, or generate human language using manually crafted some linguistic rules or lexicons. So it is basically static, okay? And here, no data need to be trained. So you can directly apply the structured logic and you can get an output. So for example, you can say calculation of text. So still we are calculating text. So still rule-based NLP works best for calculation of text. Okay. Then coming to the statistical NLP, statistical methods of natural language processing. So these are basically done, or it is basically calculated using mathematical equations and probabilities based on some historical data. So means it need to study some data initially to identify the relationships and predict the outcomes. So here it relies heavily on clean data, means the pre-processing. So you can see here the pre-processing. So the pre-processing part has a very crucial role in applying the statistical, because if you don't have a proper data, it won't be able to calculate, or it won't be able to understand what it had to give as output, and may result in some wrong output. And here in statistical data, statistical models, they apply, for example, in risk forecasting. So statistical NLP still in being used in risk forecasting and still proved to be a good method for that one. Next comes the machine learning. So everywhere now it is machine learning. So though we say LLMs, transformers, deep learning, but still it is ML. AI and ML still we talk about. So it is the big umbrella under which all these things come. So the machine learning. So this we have here some patterns are being studied. It is that the data and the patterns are being studied by the algorithms. And instead of relying completely on the human generated rules, like how we as I mentioned in the rule based NLP, like how the structured logic. So it doesn't depend on those logic. However, it requires larger structured data set with predefined features and manually extracted by humans. So here also the data need to be very much, the pre-processing have to be done quite properly, because if you don't do, we don't get a proper outcome. And so when we talk about machine learnings, we generally talked about supervised, unsupervised learnings. Like supervised learning, for example, naive bias, random forest, decision tree. So all these methods comes under machine learning, and still this method still works on, and still research people are doing research on these models. Indian languages, still these models are being worked, and still good results we are getting. However, the data need to be cleaned. So that is the more challenging part in case of machine learning. So in next comes the deep learning. So it is a bit complex, because we will be using multi-layered artificial neural networks, which are being inspired by human brains. So here the ANN concept is being used, and it automatically extracts features from raw data. So here the challenge which we have in case of the previous models, we don't have that challenge here. And it reduced the need for human guidance. So in case of the previous, suppose for example machine learning, so the human involvement for extracting the data set, the structured data set, is very much in the active role is needed. However, in case of deep learning, that active role is not needed, and the models can extract the raw data, reducing the need for human guidance during the training. And the thing is that here we need a massive amount of data. So, and that also the unstructured. In case of the previous models, we require structured data, but here the main thing and the good thing you can say is that unstructured data is very much in in use and it reduces human involvement. However, we require high computational power in case of deep learning. So next comes the transformer. So in case of transformer, uh, in case of deep learning, we can talk about facial recognition. So facial recognition, so this is very much in use these days. So we use deep learning for this recognition, facial recognition. Next comes the transformers. In case of transformers, so it is a special deep neural network designed using self-attention mechanism. So it is similar to that of deep learning only. However, it is it has an add-on thing, that is the self-attention mechanism. So for this self-attention, I will be talking in my later slides. So here the entire learning method of the data processes entire sequence of data simultaneously. So here you can do the processing, parallel processing of the data rather than word by word. So that is the advantage of the transformer models over the previous models which have been evolved. And here we require massive amount of data. So if we do on a few data, the outperform will be underfit. Underfit, it will be not working. Though you get some result, those results we cannot rely on. That comes the LLM. So it is the scale-up version of the transformer. It is actually transformer, but it is being scaled up and it is a self-supervised next token prediction. So it means that what should be the next, it can easily predict. So that is the advantage of the LLMs over the others. So in case of others, the prediction may not be accurate, but LLMs overcome those things. And however, it is required in case of massive portion of data. And also it requires human feedback. Human feedback, you may be, you have might heard in the previous sessions also, RLHF. So what is RLF? RLHF, I will be going in my later slides. So the data type, billions and trillions of words of diverse text and code. It works so massive amount of data. So all these things are being written in the paper. Attention is all you need. It is being researched and written by 8 authors, 8 researchers from Google Brain, Google Research, and 1 author from University of Toronto. And they had given a very good overview of this entire models. So I have just given the citation. So you can go in details in the paper. So the 2017 Transformer, attention is all you need. So you get an overview of the details. Next, coming to next slide. What makes Indian language difficult for AI? So coming to the first wrist morphology. So I think for example, you can see khana. Khana means eating, okay? So here, in case of Hindi, talking about the national language of India. So in Hindi, the khana based on different tense, case, gender, it has different deviation, means inflection, means one word can be represented or is written in different forms and each of the word is correct, but to this computer or to the system, each of the word is different. So in case of some languages, against the word, we have 100 plus inflected forms. So it is quite challenging to make the system understand that this is the one word and it is the inflected form. So this is a challenging point in case of Indian language. Not only one Indian language, it is applicable to most of the Indian languages. Agglutination. So here, this is this example I had taken from my native language, Assamese. So here you can see I had eaten. I had eaten this word. It can be represented in one single word. So agglutination and you can see the Dravidian languages like Tamil, Telugu. These languages are highly agglutinative compared to Assamese. This language, the Dravidian language, are more agglutinative. Then against the free word order, the structure. So we have to make the system understand about the structure. So in case of English, we know it is a yes. May I continue? Free word order. Okay. So in case of English, it is the structure is SVO. However, in so SVO stands for subject, verb, object. However, in case of the Indian languages, it is applicable, I think, for all the Indian languages. It is the subject, object, verb. The structure is SOV. So it is challenging because the structure of the English is different and the structure of Indian languages is different. And again, there is another add-on problem in case of Indian language is that the free order. Suppose Ram ne seb khaya, means Ram had eaten one apple. Again, seb Ram ne khaya. So seb means apple, Ram had eaten. So in both the way, the meaning is correct. So in that way also, the structure is challenging for the system to make it understand. Then again, the code mixing. Speakers frequently switch between languages. So you can see the example. Kal mein office gaya and filed the report. So the meaning is that I went to office yesterday and filed the report. However, the modern Indians, we have nowadays we are taking it's in style also, we can say it's in style where we mix our regional language and we mix Hindi or we mix English and we speak. So this is quite challenging these days. So the code mixing. So multiple scripts. So each of the languages have their own script and we require a massive amount in each of these languages with each of the scripts. So it becomes quite challenging and low digital resource. So as already interlinked, so we don't have sufficient digital resource. We don't have text corpora. We don't have an annotated data set, that standard data set. We don't have no benchmark. Okay. So coming to my next slide. So the foundation of the language models. So we were talking about the tokens because the word, if not interpreted properly, the outcome will be against our required outcome. So how computers see language? The computers see languages in terms of numbers. Okay, so computers only understand numbers to process any language. It may be English, it may be any of our regional language, any languages spoken in the world. We need to process every word, character, or subword and must be converted to numerical representation, which we call as embedding. So many times when we use the term embedding, the people just get frightened actually. What embedding is? Embedding is nothing but numerical representation of the text. So here whatever I will be talking, we'll be talking about the LLMs. So here In case of embeddings, dense vector capture semantic relationship because every word need to have a relationship with every other word. The advantage of LLM is that there is no limitation of dimensions. So here, the modern LLMs, they have from 768 to 4096 dimensions per token. GPT-4 reportedly uses 12,288 dimensions per token. And what we are learning from the embedding? Embeddings are learned during pre-training. So this is a part of the pre-training process. The model discovers the semantic structure from the data. So this is all about raw text, then the token IDs, then the embedding vectors and similar word clusters were together. So you can see in the next here. So one hot encoding, it is a very named approach. It is a very named, it is not the LLM. So here you can see that the vocabulary is cat, dog, fish, bird. So you can see that when we talk about the matrix, so you can see that when both cat and cat, it is 1, otherwise cat, dog, the similarity is 0. So you can see the entire matrix. So here you can see in the limitations, vocabulary explosion, 100K plus words, 100K dimensional sparse vectors. So what is there in the, you can see in the dimensions that in case of LLMs, the dimensions can be, there is no vocabulary explosions. But it is one hot encoding. It is a very initial approach being used. And then you can see no semantic similarity. Cosine, so here they had also used semantic similarity measures. So cosine similarity, there's various similarity metrics like Jaccard similarity. So any type of similarity you can use. And here you can see that it is 0. And no out of vocabulary words can means out of vocabulary words means that if those words are not present during the initial corpus, and if you are going and applying on a new set of words, it cannot find out. So this particular method completely fails for morphologically rich Indian language, which I mentioned that the Indian languages are highly inflected. One word can have multiple forms, and it becomes quite challenging for the system to identify that those derivation of the base word, they cannot identify the base word. So here you can see embeddings. So word embeddings, they're two contextual embeddings. So first let me explain what is word embedding and what is contextual embedding. So word embeddings are basically single. They are single fixed vector to each word regardless of its meaning. Okay, so basically it is a static one, and it is a fixed vector. Like if you don't have the words which are present in the, if you're training on a new word, the out of vocabulary concept will be applied, it will not work, and it will struggle with the meaning of the new word and may result in a wrong answer, wrong output. Whereas in case of contextual embedding, you can see contextual embedding, like one word can have multiple, or you can say infinite vectors based on the surroundings. For example, bank. So very common example, bank. So bank may be a river bank, okay? And it can be also a money bank where we draw financial transactions. Whereas in case of word embedding, the river bank and the money bank will have the exact same vector. Okay. Whereas in case of contextual embedding, so in the next actually slide we'll be talking. So here the river bank and the money bank have completely different vectors. And concept of out of vocabulary, that challenge is also overcome. Means if you encounter with a new word, with a new sentence, they will be able to handle that new or the rare word. So some of the word embeddings are word to vec. So this is proposed by Google in 2013. So basically they used uh, word from context and context from word. This is this is continuous base. C bow means continuous bag of words. And skip grams. So basically skip grams means the n-grams, and uses shallow neural network. So first training capture analysis, then GLOVE proposed by Stanford in 2014. So GLOVE stands for Global Vectors for Word Representation. So it captures, or you can say it combines, the local context of the word to vec. It is same just like word to vec, but the one additional thing is that it combines the local context window of word to vec. Yes.
Yes. Okay, somebody let me mute. Yes, ma'am, continue.
Yeah, thank you. So here combines the local context window of word to vec with global matrix factorization statistics. So the word to vec and the globe, the difference is that it is limited to the local local matrix, local neighbors, you can say. Whereas in case of globe, from the terminology of the method global, so it forms a matrix with the entire word of the corpus, and it's a better global statistics strong on word similarity tags. Fast text, Meta I in 2016. So it treats words as a collection of characters. So each of the words will be in characters. So how the words in characters will be talking later on in my slides. And here it is a collection of character as mentioned, and here just like the word to vec, how it is handling a single unit, it don't handle single unit. So and this method, it was performing, or it performs well good in case of Indian languages, where we have a morphologically richness in case of our words, means the highly inflected words. So this is about the word embedding. So in case of word embedding also, the fast text works better for the Indian languages. Then coming to the contextual embedding, already mentioned. So in case of contextual embedding, so it is a dynamic vector. It is a dynamic vector, and you can see here I had given here about the Biolistium Elmo 2018 by LNLP. It is a digital library, and the BERT by Google in 2018. So here both are bidirectional, and BERT is transformer based. So in case of Elmo, it is slow and sequential. However, in case of BERT, it is parallel, and it is faster compared to Elmo. Yes. So the transformer architecture. So this is the main thing where the work, how the transformer actually works, we can say, or the LLM, because LLM is the advanced version, or you can say the scale up version of transformer. So here you can see that there are two parts, encoder and decoder. So, and to encoder we will give the input, to the encoder we will be giving the input pipeline. So two things in the input pipeline we need to actually know about. The first thing is the token embeddings, and second is the positional encoding. Okay, so token embedding is basically, so this will be the input pipelines to the encoder. Okay, so just to give a rough idea how actually it works. So in case of input pipeline token embedding, so here it converts raw textual input tokens. It gives the input the raw one, because as already mentioned earlier that In case of transformers, we no need to refine the data. We can unstructured raw data we can directly use and deform into dense vector representation of fixed dimensional size. So based on the requirement, the dimensional size can be as per requirement, the dimensional size will be there. And the positional encoding, since the architecture lacks recurrence, so here the one of the thing is that here we don't have recursion, so here we don't have recurrence, so here it injects fixed or learn sine or cosine mathematical patterns. So as we talked about the hot in case of hot encoding, there is that when we talk about the cosine similarity, we get 0, but actually it is not correct. It should not be 0. So that thing, that pattern need to be read, or you can say it need to be preserved, the word order information. Okay. Then coming to the encoder part, we have the main two things, that is the multi-head self-attention and the feed-forward network. So these are two main important things. So what the encoder stack actually really does, the encoder block, it processes an input sequence. The input sequence it processes and transform it into continuous contextual representation. So here, in case of multi-head self-attention, so under the encoder, what the multi-head self-attention it does, it maps vectors into three parts, into three matrices. You can see here, here how self-attention work. In this slide, you can see that there are three things I am mentioning: query, key, and value. So here, in case of the multi-head self-attention, the mapping of the vectors into queries, keys, and values. Okay. Then it evaluates the internal dependence of the words across the tokens were simultaneously done, and here scaled dot product formula is used. Okay. Next, then feed forward network. So in the feed forward network, it is basically the position wise of the tokens. It consists basically of two linear transformations separating a non-linear activation layer. So the non-linear, we also call this ReLU. You may heard this abbreviated word, or you have come across also. And it refined the features positionally. So the position, because when a word comes before and after, suppose good, the thing is good, the thing is not good, the meaning the change completely. So the position of the tokens matters a lot. So it seems a small thing, but it becomes quite challenging for the computer, or you can say the system, to understand what we do. The human brains are very active, they can easily catch in all modified form, but for the computer it becomes quite challenging, because it may be also there in case of Indian languages, like in case of my language, in my place, I am from the state Assam, Northeast India. So we speak Assamese, but the words which we speak, like we have Upper Assam, Central Assam, Lower Assam, and each of the words, when spoken by people, have different tones. The tone of the words are different, and the writing is also different. So the whatever we write in text is basically the Upper Assam script. So in that case also it becomes quite challenging to understand the things. So these are some of the challenges, just talking only with respect to my region, but to the entire India with so many languages, so many regions, same languages, different community speaks in such a different way, so it becomes quite challenging to align in one way. So then comes the residual connection of the add and norm. The add and norm means adding and normalizing. So it utilizes both the sublayers. So it utilizes both the sublayers, and it stabilizes to deep optimization steps. So in the encoder step, so these things are being done. Then coming to the decoder stack. So in the decoder stack, you can see that mainly in the decoder stack, it handles the sequence generation auto-regressively, predicting one sequential target token at a time. So it is not that they will be doing at a time many things. So the token, everything is the token. So they handle the token very, handle with care, which we can say. So here, Marx multi-head self-attention. Marx multi-head self-attention. So here it implements causality constraint by masking out future tokens. Ensuring predictions can only reference past context. So past context of the word is also being taken. Then encoder decoder cross attention. So pulls keys and values. So already I'm talking about this keys and value. So here it's generated directly from the finalist encoder output. So from the encoder stack, we get that output while taking the queries. We need to take the queries also from the lower decoder stack, okay, to align input output semantics. So that is a very crucial thing which we need to know. And then the position wide feed forward network. So the position really matters. So this, in case of decoder stack, there's just mirror the encoder stack, and then this layer refines representation before passing data upward. Okay, upward. So the encoder decoder stack they had done. Then the final output. So I had already talked about the input pipeline. Now the output embedding, what it is there. So projects the decoder vectors back into massive logic vector. So what is logic vector? So that is one important. So logic means it is a raw unnormalized numerical scores generated by the language model in the final layer. It means that which word to need to be ranking. So based on those ranking, only the output comes. And this is done through this softmax formula. So you can see here in the right hand side of this slide. So this is the formula they were using. And what they used to do, they transform the logics and into normalized probabilities, picking the highest confidence token as the next structured output word. So after that only they will give the result. Means you may say that it is like a black box to us. We don't know how it actually works. It is just like a black box to us. We get the input, get the output, but actually how it works. So here you can see in the left side of the slide, the matrix, you can see that in case of hot encoding, so there we were not getting the similarity scores, but here we had got, and the one which have the highest will be taken, and accordingly the model will work on this. It's an example I'm just giving you. So based on the work which we will take, so you will get the real output. So why transformers revolutionize NLP? So the first and the foremost thing is parallelization. So unlike RNNs, so RNNs we basically used in machine learnings and deep learnings too. So here the parallel processing and faster training. So this is one of the very, the most positive thing of transformers and the scale up version, that is the LLM. So long range dependencies, every word directly attends to every other word. Means there is no gradient problem. There is no limitation of dimensions. We can work on every word with every other word. Transfer learning. Pre-train once on massive data, fine-tune safely on specific tasks. One model serves thousands of use cases. So the whatever I talked right now, everything is here. Scalability. So here performance scales predictability with more data and parameters. Multi-head attentions. multiple attention had captured different relationships simultaneously. It talks about syntax, semantics, co-reference, and everything, every other thing which is required. Those things are being attended to, and then the word or the token is predicted and given as output, and positional flexibility. So the what already I had talked here about the positional thing, positional encoding, so that is being highly addressed in this model. So some of the emergence of large language models you might have heard, you might not have heard. So just giving you an idea. So GPT-3, Llama 3, Gemma 2, Mistral, DeepSeek, Indic LLM. So here you can see that these are some of the models where Indian languages work, like Llama 3 and Indic LLM. So especially it is based on AI for Bharat 2024. The government and the researchers in India are working and trying, to make the regional languages digitally strong. So tokenization and Indian languages. So here you can see how the words are being sub-word level and how it is being done in character level. So here the memory use, the vocabulary, GPT-4 uses 100K tokens. Indic covers almost 200K plus Indian script. So fertility. So fertility you had heard in case of human beings, the human body, but there is also another fertility which is being used in case of languages. So basically it is not, it is called token fertility. So token fertility means it is the average number of model tokens generated per human body. Okay, so if how we will say that it is working or it is not working or its efficiency. So if you have a lower fertility, it means fewer tokens per sentence and the processing speed is good. So the fertility also matters, and OOV handling. So unknown words are broken into smaller known units, critical for morphologically rich Indian languages, and after that we can handle it. So I will show you later on. And next slide, I will show you how it works. Not this. Okay. So word level, character level, word level, character level, subword level. So these are some basics already I have talked about. However, this character level Indian language, Indian script is working good. In case of character level, we are getting a better result and produces 5 to 10x more tokens than English. That is the one thing we have to see in case of the regional languages of India. And when we come about the subword level, so you can see here I have the best choice, the BP per sentence piece. So BP means byte per encoding per the sentence piece. And the the Indian models, Indic Bird, Muriel, XLMR. So what are there we are talking? It is coming on our coming slides. So byte per encoding. So byte per encoding. So here, how it actually works. So you can see how it is actually working. So it starts with characters. Start with characters. You can see here that in it, the tokenizer starts by adding all unique individual characters found in the text to its vocabulary. Okay, then it pre-tokenizes and track frequencies. So words in the training text are split into characters. So in that case only each of the characters will be addressed. Then the adjacent pairs, the count all, and in case of a second point, you can see count bigram frequencies, count all adjacent characters or token pairs. Then Mars, the most frequent pair, means those who encounters most in the uh, when you make the vectors. And finally, the final vocabulary. So to make you understand about this byte pair encoding, I may require another 1 or 2 session, because here you have to know the actual mathematical how actually it works. This I tried to give this and brief brief outcome how actually it works. Means you start with the characters, count bigram frequencies, merge the most frequent pair, and the final vocabulary. So this is how the out out of order vocabulary is addressed, and we get the answer, the required answer, without conflict in the meaning of the word, that is the tokens. Okay, then the sentence based language agnostic tokenization. So I have taken this one from the paper tutor and research son from 2018, because at that time only it was being proposed, this concept, and it works on our Unicode script. As all of us know, our Indian languages are written in Unicode script, and there is no word boundary assumption. So you don't require spaces to define words. So especially this works for agglutinative languages like Telugu, Kannada, or Tamil. All the because Dravidian languages are mostly agglutinative. So no word boundary assumptions. Reversible tokenization in both way. In both way, you can construct the meaning of the tense and word. Like if the sentence to word to sentence, both can be done, and the meaning can be preserved. So BP plus unigram LM. So here, as already I mentioned you, so byte pair encoding, we need a separate session with details and how the unigram language model actually works. Just try to give a brief idea, but ample amount of opportunities to work and research on your native languages. You can do ample amount of opportunities, so you can go and search in depth and work on. So you can see that it is being used in all the versions of these models. So Gemma, IndicBird, Indic LLM. Okay, so how this word piece actually works, you can see here how it works. Actually start with character vocabulary for all sentences. The learn merges by maximizing likelihood of training data. So there is model maximizing likelihood. Then here you can see that I had given hash. So it marks continuation, not word start. Okay, so you can see like playing, play, then in. Means there it is not a complete word, but there is something. Okay, there is something. So handles out of vocabulary by decomposing to known subwords and applied greedily at inference time. Long maths first. So the greediness need to be there for the long maths word. Then you will get the meaning of the token. So you can see here, I had given here some example. Like come to the Hindi meaning. So here it is nationalized, Rashtriyakrita. So here in case of GPT model, you can see 6 tokens. 6 tokens, it is being generated. Whereas in case of IndicBird, 2 tokens. So this is some of the tokenization challenges you will see in different languages. Different language, I have given various examples. So there is one example of Tamil also here. So in case of IndicBird, it is less, whereas in case of GPT, they split into more tokens. They means every single till how much it is possible, it is being splitted. So this is here how it works. So same thing. So if you don't do the embeddings properly, you come out with a wrong prediction. If you go with an unified embedding, the semantic, the correct prediction. Okay. So here, this is a case study of some of my students who had done on some of these models, and like sentiment, post tag, POS tag, and machine translation. And also I had reflected about the token fertility. So here you can see how actually the model is just trying to give an idea actually how the models are working. So among them, you can see that Indic bird works the best. However, you can see Indic bird also works best for the token fertility because, as already mentioned, I had mentioned that if you have low fertility means faster processing speed. Faster processing speed means you can work on large and massive data. So modern LLMs for Indian language. So these are the multilingual models, especially for Indian languages. So I had highlighted Indic BERT, Muriel, Indic LLM. So Indic BERT, it had done for 12 script of Indian languages, and it had done for natural language understanding tasks. In case of Muriel, it had done for 17 languages, and especially in Indian languages, cross-lingual transfer. And Indic LL Llama based all scheduled, all the 22 scheduled languages for the Indic text generation. So these are the three models which are performing good in Indian languages, and various works are being done. So under two organization, AI for Bharat, which our government had been promoting for the Indic languages, and Muriel is done by Google. So others are also being done for various languages. So Indic part. So Indic part, you can see here, it is best worked for classification, text classification, named entity recognition, NER, and POS tagging, because the POS tagging, parts of speech tagging, because if you don't tag the words properly, it is not possible. If you don't tag the words proper, it is not possible to understand the meaning, because as already mentioned, fly is an insect, it's a noun. Fly is an verb, it's an action. So in case of English language, we have limited ambiguity words, but in case of regional languages, in each of these languages, we have quite challenge. It is not that only we have two different, maybe sometimes same parts of speech but different meanings. Like for example, like Akash. So Akash, it is a sky, and Akash, it may be a name of a person. So both are nouns. So in that case, it becomes quite challenging to derive the meaning, what actually the sentence is trying to speak about. So sometimes same words with same parts of space, same words with different parts of space, and it is the ambiguity is very much in case of regional language. So Indic BART by AI for Bharat, Muriel, Google Research India. So cross-lingual transfer, it is working on this one. So so here you can see pre-training on MLM. So MLM means masked language modeling. So masking of the language is done, and the translation of the language modeling is also done. Then here XLMR by Meta AI, the Llama family. So here actually this model speaks something of Indian language. So you can see in the down I had mentioned why Llama matters for Indian AI. because it open weights, fine-tunable on Indic data. Projects like Indic LLM, Servan 1 are all Llama based. And so you can see that, so till I had written or I had defined here the 4 versions about their characteristics. So here the Llama family works for Indic languages. So if you plan for any research on your regional language, especially Indian languages, you can do research on these models and you may get some good output. Good output means because here the Indian language characteristics are being understood by these languages. So here, how it actually works: data collection, data pre-processing, tokenizer training, pre-training, supervised fine-tuning, and RLHF/DPO alignment. So the previous 5 things, it is already known to you. However, this RLF, DPO alignment, this may be new to you. So RLHF, it is the reinforced learning from human feedback. So the model takes the feedback from the human. So they go for 3 steps. Basically, they go for 3 steps: supervise, fine tuning, then they reward the model training, and reinforce learning. Means based on the score of the words or the feedback, they take the preference and optimize. So it is not that you give whatever and they give output. No, they optimize and give you the best one. So DPO, so direct preference optimization. So in this algorithm, they try to align the LLM models output with the human preference. So this is one of the, one of the most advantage thing in case of these LLMs. So how actually it works here, you can say generate, which already I talked about, human rank, reward model, then PPO, DPO. Okay. So applications and methodologies. So here where we can work on, where research are being going on, which are the most emerging research areas still Indian languages can, as in Indians, we can work on. Text classification. Under text classification, we can work on sentiment analysis, emotion, hate speech, topic classification. Under sequence labeling, named entity recognition, because in case of named entity recognition, a name can be a place, a name can be name of a person. So it based on the domain, it is different thing. And named entity recognition, the base now it had been upgraded to nested named entity recognition. Then machine translation, text summarization, question answering, very much in demand in everywhere. Every time Mia will comes, right? Mia will come and say, "May I help you?" We just put our question, they give answer. So very much we have in English, but we don't have in our regional language. So very much in demand. Health and social. So here depression detection from the text itself. Somebody is commenting on a social media. From the text itself, we can get an idea how the person is all about, or what the person mental health is all about. We can easily identify from this depression detection, suicidality prediction. So sentiment analysis. So here positive, negative, neutral. Based on that, still Indian languages we are working on. And here you can see in IIIT Hyderabad, they have one project on the AI for Bharat Indic sentiment, where they had done great work on regional languages of India. So already I gave you an example about the code mixing. The key challenges Suppose the example, you see this movie tha bhai ekdam alag level ka. So detecting sentiment across languages in one sentence. So you can see that how the people speak, how actually not people, how we the modern Indian speaks. In the current trend, we are speaking in this way. So we have to also upgrade the system in that way. So quite challenging. Sarcasm, बहुत बहुत अच्छा काम किया. So here this how the tone is being, how it is being spoken, actually it matters a lot. So it may be a very softly way, like बहुत अच्छा काम किया बेटा, like बहुत अच्छा काम. Sometimes we may select to criticize him. बहुत अच्छा काम किया. Like the tone may be different. Then and in the expect level, खाना अच्छा था लेकिन service खराब. So we are putting multiple sentiments in one sentence. So like here itself in code mixing, sarcasm, expect level, we have 3 different area of research where we can work lots and lots for our regional languages. So you can see here how actually it is working. You can see here how IndicBird wins. Mural is close to second. The data quantity and quantity. You can see clean 10,000K samples with noisy 100K. Data annotation quality critical for Indic enemy. Still, the annotation is a problem. Still room to grow. So human agreement, still there is a gap of 5. Still we are not reaching the 100%. Still the gap is there. So emotion detection, emotion is not level to positive and negative. There are various sections. So we are running short of time. Just I will skip the slides. So emotion detections, these are applications. So here how it works in Hindi. I'm trying to show it in the graph. Then hate speech and toxic comment detection. So the toxic comment detection, it is quite challenging because the toxicity is spreading in the in the social media site so much that it really needs to be controlled, and it is a big societal problem these days for a country like India, where we have so many country communities, so many political scenarios, so many things are coming. So this is a very challenging and a very emerging research area where we can talk about, we can do research. So hate speech detections, hate speech AI versus you can see hate speech detections, dictionary based, fine tuned GPT, XLMR, embed, indic. But so these some of the some of the refined works of done in Hindi. Depression detection. So already talked. So many to 200 million plus people in India are affected by mental health condition. AI-powered early detection from social media and clinical text can bridge the gap created by this 1:1 lakh psychiatrist to patient ratio. So it is really a need for us. So again, we have to also go for the ethics and responsible AI in case of depression detection, because the privacy we have to do clinical validation, augment, not replace, informed consent, bias awareness, and crisis. Means bias in the sense that you know someone, you make the data accordingly. No, it should not be. Whenever you go for the data, the bias, it should be unbiased. Otherwise, the depression detection cannot be a successful one. So irrespective of caste, religion, reason, it need to be done. Parts of speech already talked about. So Indic languages and challenges. So how actually it works, machine translation, text summarizations. So these are some of the areas where we can work on. So deployment, end-to-end NLP pipeline, data to deployment. So how actually it works on. So same process, same process for older models, just the architecture is the different. Otherwise, the thing is same. So how we can go for production, how we can go for from our system to the product. We can make product in that way, and we can promote our regional languages. Some of the tools and frameworks which we require to make or to develop, you can say metrics. So these are basically, these are the metrics. So this is a model performance, it is radar model performance. So F1 score, blue, rug, perplexity, these are some of the metrics which is being standardized for assuming that the prediction or the outcome is a correct one. Common challenges in NLP system. So data scarcity, which we are already talking about from the beginning, that digital data still we are in deficit, or we can say that we are having deficiency, digital data deficiency in Indian languages. This is one of the challenges. Morphological explosion, you can see why this matters for AI. Each form is effectively a separate word the model must learn. So many inflection, so the model must learn each and everything. They cannot skip. Missing benchmark, we can't improve what we can't measure. So that is the main thing, because if we don't have a benchmark, we cannot say, like we can see so many research papers are there. Some say 93%, some say 97%, some say 99%. But we cannot say that all are giving the good result or their result is very much efficient, because there is no benchmark. So that is the shortcoming in case of research in Indian language. So missing benchmark. Dialect problem, which I mentioned, that a language, when community from different communities speaking one language, if they are from different geographical location, the dialect changes. So very challenging for the system to understand. Low resource language spectrum. So here you can see that like Hindi, Bengali, Tamil, they have a medium high resource. Medium Telugu, Marathi, Kannada, Malayalam coming in medium. Low Oriya, Assamese, Punjabi, Gujarati, they are in low category, low resource. Very low resource, you can see Boro, Metis, Santali, Maithili. These are Indian scheduled languages still not being in the digital platform, very low and near zero. You can see that here are some of the, these are Indian languages, but you can see that they are almost nil. Still, they have to start from ABCD to start the digital data set. So this is the scenario of in some of the Indian languages I have tried to highlight. So here I want to say every language that AI does not understand is a community that AI cannot serve. So until and unless AI reaches to us, reaches to our regional language, then only it can serve our community. The gaps are not just technical failures, they are equity failures. And equity failures have real consequences for real people. So this is given in our research report by AR4 Bharat in 2023. So we have to really work on our regional languages so that AI can have equality to each and all of us. So future direction and conclusion. Indic LLMs at scale, multimodal AI, speech LLMs, mental health AI, agentic system, low resource cost. So these are some of the areas where we can work on, and we can make our regional language upgrade and making it equivalent to other high resource languages of the world. So these are the key takeaways. token data, tokenization, transformers, fine-tuning, and finally the Indian language AI. So with this, I conclude my presentation. Thank you.
Thank you, ma'am. Any questions from anyone? You can unmute yourself. How you can start the implementation things or anything? Any questions from your side you can ask. You can unmute yourself.
You can
Hello.
also drop to my email for any of these queries. So we had regarding mental health, we are having one project with Vietnam, with the Vietnamese, and from the parts of speech and toxic and hate comment, we have project from DST and ANRF. So if you like to ask me any question, you can drop me in my email also, because it's a Sunday and lunchtime maybe. So thank you all the participants for hearing, for their patience hearing for 1.5 hours screen time.
Thank
Thank
you,
you.
ma'am. I will be definitely in contact with you as you have lots of projects are there. So we'll talk in detail. Here is also in our KIT another KISS university is there, which is a tribal university. So where we have 64 different languages communities are studying, all from KG to PG, everything is free for them. So if we can collect some data, means it will be easier for us to collect some data, either speech format or text format. So let us see what collaboration we can do in future. So thank you once again, and
Thank you
thanks
so
to
much.
all. So next session will be at 3 o'clock by Balkrishna Bal from Nepal at 3 o'clock. Thank you,
Okay.
ma'am.
Thank you, sir.